In the previous videos, we discussed the properties of determinants. In that, first property I discussed. So, what is that first property? The first property is if we have any determinant, for example, here it is A1, B1, C1, A2, B2, C2, A3, B3, C3. If we have any determinant, then if I interchange rows into columns, so what is that? I taken it as delta 1. So if I interchange rows into column wise, so that is, if this is the one row, that I am writing in terms of the column wise. So A1, B1, C1, A2, B2, C2, A3, B3, C3. Clear? So whatever I have the row, first row I am writing it as first column, second row I am writing it as second column, third row I am writing it as third column. So first row I write it as column 1, second row A2, B2, C2, A2, B2, C2, second row I am writing it as the second row as I am writing here it is second column, third row I am writing it as third column. So if you interchange rows into columns, so my dear students, already we know transpose of a matrix. So what is the transpose of a matrix? If I have any matrix A here, A1, B1, C1, and here it is D1. If I have any matrix A, then transpose of this is nothing but AT. The rotation will be like this. Clear? So therefore, so A transpose is nothing but I should interchange rows into columns. So this is row, I am writing it as column. So C1, D1. So this I can call it as A transpose. A transpose means what? The given matrix, if I write that rows into column wise, A1, B1, C1, D1. So this first row I am writing it as column. Second row I am writing it as second row I am writing it as column. So if I write like this, then this we can call it as the transpose of A, the given matrix A, and it is denoted by A transpose. This concept we discussed in the matrices topic I discussed. Clear? So this is the concept of the transpose of a matrix. And similarly, if you come to into the determinants, here I have considered the one determinant. Clear? So this determinant, if I interchange rows into column, so this is nothing but first row I am writing here column, second row I am writing here it is second column, third row I am writing here it is third row I am writing it as third column. Here from this determinant I interchanged every rows into column wise. So therefore this we can call it as transpose of this. Clear? So you can say that this determinant is the transpose of this, we can call like this, or we can say just simply we interchange rows into column. So therefore, so the value, what is the first property? For any determinant, if you interchange rows into column, then the value of the determinant will not change. The value of the determinant remains as it is. Thus that is the first property I discussed. I hope you understood. And now today's class I am going to discuss the second property. So what is the second property then? So here, my dear students, in the second property we can see already I wrote the statement, or you can take it as the statement. So what is that? If any two rows or columns of a determinant are interchanged, then sign of the determinant changes. So first of all, I tell the meaning of the statement. So what is the statement then? They given you that if any two rows or columns of a determinant. So let us consider, I am taking here this, I am taking one determinant. Let delta is equals to A1, B1, C1, A2, B2, C2, A3, B3, C3. Clear, my dear students? If any two rows or columns of a determinant are interchanged. So before that, first I consider one determinant. In this determinant, so let us take this as delta. Let delta is equal to one determinant I considered. So now what they telling here is, if any two rows or columns of a determinant are interchanged, then sign of determinant will changes. So this is the one determinant delta I taken here this. Now I will take another one delta 1. So I am taking here this delta 1. So delta 1 I am taking in such a way that here my dear students, Delta 1 I am taking here this as A3 B3 C3, A2 B2 C2, A1 B1 C1. This is the one determinant I considered. Now what I did here, from this determinant I interchanged the row 1 and row 3. Here whatever I have in place of row 1, that I wrote in place of row 3. Third row I wrote those elements, and whatever we have in the third row I shifted to the first row, A3 B3 C3. Please try to try to identify the difference. So what is that? From this determinant I interchanged the row 1 and row 3. Whatever the elements present in the row 1, that I wrote in place of row 3, and whatever elements are present in the row 3, that I wrote in place of the row 1. So my dear students, what is the meaning of the second property is, if for any determinant, if you interchange any two rows or columns, here in particular this here it is, while to verify this theorem, or you can take this property, I interchanged the row 1 and row 3, and that I'll write here like this, row 1 here, or else I'll write here I'll write row 1 interchanged row 3. So symbolically we will write like this. Clear? So I shifted here this. From this row 1 I wrote here and row 3 I wrote here. Clear? So that I am writing symbolically like this. Row 1 interchanged row 3. So clear? It means that what? It means that here whatever in place of row 1 is there, that elements I am writing in the here, and these elements I am writing in this place. So that is I wrote in notation symbolically we should write like R1 interchanging R3. Now the meaning is, for any determinant, any two rows, either you can take rows or you can take columns. If you interchanged, then sign of the determinant will changes. Clear? That is the property. Now that is the statement. Now I am going to prove. So to prove this, let us take one determinant. I am taking here this one determinant. Now I simplify this. Clear? And then another one determinant I am taking it as delta 1. What is delta 1? Delta 1 is nothing but after interchanging the rows from this determinant, whatever I am getting, that I wrote here. Now I will simplify this one. It means I will find determinant value of this, and also I will find determinant value of this. After finding that, we can conclude that sign will changes. So whether it changes or not, now I am verifying here. Therefore I am written here this, where I wrote verification. For this statement, whatever we given the property to, whether it verifies or not, that I am going to check. Clear? So simple it is. So just I consider the one determinant. So my dear students, already we know how to solve the determinant of the order 3. So first what should we do? We should put the sign that is, this is plus minus plus minus plus minus plus minus plus. Clear? Now I will simplify this one. This determinant I will simplify, that is expanding along row 1. So I am expanding now along row 1. So what is the determinant value then? Determinant is equals to A1. So first element we should write like this with this sign, plus into A1, plus into A1. Now leave this row and this column, that is first row and first column we should leave, and then we should take the determinant of the remaining elements, that is this is expressed, the 3 cross 3 determinant I expressed in terms of the 2 cross 2. So what is that? Here it is, we should leave this first row and first column. So therefore after leaving this row and this column, we should take the determinant value. So how to find out that? B2 into C3, it's correct. B2 into C3 minus of this element into this element, B3 C2. Please, if you don't know how to find the determinant, please refer my previous videos. In the previous videos I discussed how to find the determinant value of the order 3. You can refer there. Clear? And now my dear students, minus of B1 minus of b1, again here it is minus into b1, minus into b1. Now again leave this column and this row, and here it is, we should multiply a2 into c3 minus of, here it is, a3 into c2. Clear? b1, leave this second row, second column, first row. So a2 into c3 minus of a3 into c2. Next plus c1 into plus c1 into, again leave the first row and third column. After leaving this first row and third column, a2 into b3 minus of a3 into b2. Clear? So this is nothing but the determinant value of delta. Clear? Please, my dear students, whenever you are watching the videos, please make sure that you also watched my previous videos, because this already I discussed how to solve this one. If you watched my previous videos, then only you will come to know how I am writing here this one. Clear? So please try to, whenever you are watching the videos, please refer my previous videos so that you can understand easily. Clear? Still, if you have any doubts, you can comment me. I reply for that. Clear? Yes. Now, my dear students, here, now this is the delta I considered, I expanded, so this is the value I got. This is the determinant value. So write as up to here we should simplify. Further, no need to simplify. Up to here, this is enough for us. Clear? And now consider the delta 1. So now delta 1 is nothing but what? Already I told you. What is delta 1? Delta 1, that is determinant 1, is this is nothing but just I interchanged the row 1 and row 3. Clear? And now, my dear students, to simplify this delta 1, I am expanding along row 3. Now I expand along row 3. Already I told, either you can expand along row 1, row 2, row 3, or you can expand along column 1, column 2, column 3. The value will be same as it is. Clear? But now I am expanding along row 3. So clear, additions. And please see, whenever we are whenever we are finding the determinant, in that case we should write the sign like this. This is plus minus plus, minus plus minus, plus minus plus. Why I should write like this? That I discussed in the previous videos. Clear? And now I am expanding along the row 3. So therefore, delta 1 is equals to here plus a1 into, again here it is, leave this row and this column. Now b3 into c2 minus of b2 into c3, Next, my dear students, minus b1, here it is, minus b1, again leave this row and this column. So a3 into c2, here it is, this row and this column, a3 into c2 minus of a2 into c3. Clear? Next, my dear students, next here it is plus into c1, again leave this row and this column. Now solve remaining, a3 into b2 minus of, here it is, a2 into, here it is, a2 into b3. Clear? Now what I will do, I take minus sign outside. From this I am taking minus sign outside because I am expressing this delta 1 in terms of delta. I wanted to express this in terms of delta so that we can write the relation clearly, whether sign changes or not. To understand that purpose, I am taking minus sign outside, because here see, here you can observe, here it is, in delta b2c3 is first, here it is, it means b2c3 is positive, here b2c3 is negative. To express in terms of this, I am taking minus sign outside. So here from this, if I take minus sign outside, so first I write this term, already minus sign taking outside, this term I am writing first, b2 C3. And next my students, here it is plus, but more minus I have already taken outside. So therefore I am writing here it is minus B3 into C2. So please remember my dear students, whenever you are taking minus sign outside means anything if you take common, the sign anything you take from the common means after taking the common, if you simplify this further, again you should get this step only. Like this we should verify. So here it is minus into B2C3, minus into B2C3 I got here it is. Here I should write minus because again minus minus plus I should get. So therefore I am writing here it is minus plus B3C2 I have. Clear? Like this we should take the common. And again here it is my from this also I am taking minus common. So if I take minus common, here it is already one minus is there. Minus will become plus, and again I will write first this term A2C3, and here it is my difference. Here it is plus is there. Here it is my plus is there. So what I will do here is from this I am taking here it is. From this I take minus outside, and here I will write minus B3C2. Clear? Because here it is A2C3 is, if you simplify this, again you are getting this one or not. Please check here it is. Because if you take the minus and I am taking minus and outside from this, so this will become plus and this will become minus. So plus B1 already outside is there. Just I am verifying this. So plus A2C3 and here it is B3 A2C3. Yes, little bit. Yes, it should be. I should write like this. First I will write this one A2C3 and here it is plus is there. I will change the sign A3C2. Clear? And next my dear students, from this plus here it is again, sorry, I am taking again from these two, I am taking minus sign outside. So if you take minus sign outside from this, so plus into minus C1. Here is again I will write first this term A2B3 and next this one minus A3B2. Clear? Here it is. From this again I took the minus sign outside. So minus, if I take minus sign outside, plus minus C1 as it is. First I wrote this term A2B3, next minus A3B2. Clear? And now my dear students, again I will write delta 1 is equal to, from these three terms I am taking minus outside because the here it is the delta I am comparing with delta. I should express, I am finding the relation between this delta 1 and delta. So for that reason, here plus positive A1 is there, but here it is negative A1 is there. To make it positive, again I am taking minus sign outside. So if I take minus sign outside, so what is remaining here? It is minus, and inside here it is A1. You can write here minus I am taking outside. From these three, I am taking minus sign outside. So minus outside, then here it is positive A1 B2C3 minus B3C2. Next, here it is minus already I took outside, so here it is plus, here minus will become plus. So therefore I take here this minus B1 and remaining as it is A2C3 A3C2. Again it is minus is there, minus already I took in it is. So now I take plus, minus into plus is minus, and here it is C1 A2B3 minus A3B2. Clear? So this right inside the bracket. Clear? Now my dear students, this delta 1 is equals to minus as it is. You can observe here this is nothing but delta only. A1 B2C3 minus B3C2 minus B1 A2C3 minus A3C2 here. Plus C1 as it is A2B3 minus A3B2 A2B3 minus A3B2. So therefore this minus sign as it is. So this value is nothing but, so this is nothing but this value. Can I substitute it as delta, because this value is here I have already calculated. Delta is nothing but this value. So therefore delta 1 is equals to minus delta. I hope you understood. What I did, my dear students, here just I verified this property too. What is that? For any determinant, if any two rows of a determinant, this is the one determinant. If to this determinant, if any two rows or columns, but here in this particular example or in this particular case, I interchanged the rows. So if any two rows, if you interchanged, then the value, then sign of determinant changes. Then this sign is changed here. Clear? Then the sign of determinant will changes. So this is the verification for this second property. Any doubts? I hope you don't have any doubts. So further, still if you have any doubts, you can comment me. I will reply for that. So, my dear students, now I will take one example. Then you can easily understand this concept. Clear? So now I will consider the one example for this property. Yes, my dear students, the example that I wrote on the board, that is delta is equals to 2 minus 3 5 6 0 4 1 5 minus 7. So this is the one example I am solving to verify the second property. Just only we solved the theory part. It means generally I solved this property. Now I am taking particularly one example I am taking here, my dear students. So what is that? Delta. That is nothing but determinant. One determinant they given to you. Now I will solve this one. And next, after solving this, I will find value of this determinant. After finding this, again I will take another one determinant that is obtained by interchanging the rows of this determinant. Then whether the sign will changes, whether this property verifies or not, that I will check. So to understand this property, first my dear students, solve this one. So here it is, determinant is equals to, I am expanding along, either please remember, for any determinant, either you can expand along row 1 or row 2 or row 3, or you can expand along column 1, column 2, column 3. So for now I am expanding along row 1. Clear? So either you can expand along row 1, row 2, whichever is convenient for you, you can. The answer will be same as it is. Clear? So, but before writing this, what should we do? We should interchange. We should put the sign. This is positive, negative, positive, minus, plus, minus, plus, minus, plus. Clear? So now I am expanding along row 1. So therefore, determinant is equals to plus 2. 2 into, again leave this first row and first column. 0 into minus 7 is 0. Minus of 5 4s are 20. Next, minus of minus 3. Minus minus plus 3. Again leave this column and this row. 6 into minus 7 plus minus minus 42. Minus of 1 into 4 is 4. Clear? Please remember, this sign is only for the outside elements. Means after the bracket whatever I am writing here, while writing these signs I put here, this plus minus plus 6 minus plus minus plus minus plus. This is only for the expanding along row 1 or not, or the expanding along row 2. In that case, this sign will use again, but while solving inside the bracket, it won't use. Clear? So please, as I told, please refer my previous videos. There I explain how to solve the determinant of the order 3. Clear? And next, my students, here it is plus 5. Plus 5, again leave this row and this column. 6 5 is 30, minus 1 into 0 is 0. So further if you simplify, delta is equals to 2 into minus 20 plus 3 into minus 42 is 42 minus 4 is minus 46 plus 5 into 30 minus 0 is 30, and this is equals to, here it is, minus 40 plus minus minus 46 here into 3. 46 into 3. 3 6 is 18, 4 3 is 12, plus 1 is 138, plus 5 into 0 is 0, 150. Further if you simplify this, here it is 150 minus 138. So 150 minus 138 is, here it is 12 plus 12 minus 40 plus 12, and here it is 40 minus 12. Clear? So it is 10, 8, 2. So therefore delta is equals to minus 28 is the determinant value of this. This is rough, just tables. Clear? Multiplication I did. And next, my students, so this is the one determinant I have. I calculated the determinant value. Let us take another one, delta 1. So now I am taking the delta 1. That delta 1 is obtained, that is interchanging here, interchanging row 2 and row 3. Interchanging see here, you can interchange any two rows or you can change any two columns. That depends on you, but I am taking here this just to verify that I am taking interchanging row 2 and row 3. Interchanging row 2 and row 3. Please remember this in symbolic form we will write like this. It means that row 2, in place of row 2 elements we should write it as row 3 elements, in place of row 3 elements we should write it as row 2 elements. That symbolically I write. So therefore that I am taking here this delta 1. So what is that? Here it is row 1 as it is 2 minus 3 5. But here it is row 2 and row 3 interchange. It means this all elements I will write here and these all elements I will write in this place. So that is 1 5 minus 7 6 0 4. Clear? I interchanged this. So row 3, whatever in place of row 3 is there, that I wrote in row 2. Row 2 elements I wrote in row 3. Clear? And now further simplify this, my dear students. So this will again here first change the sign, plus minus plus minus plus minus plus minus plus. So now I again here this. I'll expand this one, expanding along row 3. I am expanding either again here you can expand along row 1, row 2, row 3 or column 1, column 2, column 3, but I am expanding along row 3 because one term is 0 is here. So simplification will be easier. For that purpose I am taking here this, I am expanding along row 3. So if you expand along row 3, so therefore delta 1 is equals to, here it is, here what is that? First plus 6 into, again I am expanding along row 3, this is your row 3, so plus 6 into, leave leave this column and this row, and here it is minus minus plus 7 3s are 21 minus 5 5s are 25. Clear? And next minus 0 into anything is 0, either you can write or you can leave. Again here if you leave, but I will write to see it proper way. So for that reason I am writing this one here, these elements. So 0, leave this row and this column. So if you leave this row and this column, here it is 2 into minus 7 minus 14 minus of, here it is. Next 1 into 5 minus 5. Further plus 4 again this row and this column. 5 2s are 10 minus 3, another one minus. If you are multiplying this side means we should take one minus. So plus 1 into minus 3 is minus 3 minus plus 3. Further simplify this. Delta 1 is equals to 6 into minus 25. Here it is minus 4. Clear? And next 0 into anything is 0. And next so delete this one here only. So this term is cancelled. Only remaining is plus 4 into 10 plus 3 is 13. Clear? So now here it is delta 1 is equals to minus 24 plus 13 4s are 452. So therefore delta 1 is equals to 52 minus 24. So 8 2. So So here it is delta 1 is 28. Clear? Yes. Now you should clearly verify or you can understand easily the meaning of the property 2. Please, my dear students, you can observe or you can understand the property 2 very easily from this example. What is that? I consider the one determinant. I solve this determinant. Whatever I got value here it is, that is negative. But here this, that will here this, that is minus 28 I got. Now the same determinant I just interchanged the two rows. So that two R2 and R3 just I interchange there. This row and this row I interchange here this. After interchanging this, interchanging, if you calculate this further, again I got the same value, that is 28 only, but the sign is different. There I got that I got negative, but here I got positive. So therefore, as the property told here it is, that is sign of the determinant will changes. So therefore, for any determinant, if you interchange any two rows or columns, then the sign of the determinant will changes. So by this you can conclude, for any determinant, if you interchange the any two rows or any two columns, then we should change the sign, because I verified here. So this is the second property, very important. And please, my dear students, don't be afraid if you are confused with the proof. I think normally generally they won't ask proof for this. Clear? But still we should know how the property is verified or how to solve. Sometimes they may ask in annual examinations. So please, if you understand the property, then it's good. Otherwise, if you understand the verification, then it's good. If you won't understand means also don't worry. Just remember the results. Clear? Yes. I hope you understood. Still, if you have any doubts, please comment me. We will discuss the remaining properties in the next class. Thank you.